my name is Tasneem. I'm the senior manager at 98 Percentile in the HR department. And today we did a wonderful drive with XLR. It was amazing right from the very beginning, from the very first day when I got in touch with them till today. I think it was an extremely smooth journey with them. There were multiple follow-ups done by the representatives in order to check that we would be, what time we would be coming, how many people would be coming, what vehicle we would get. To that extent, they were so precise in giving all the information to us. It was extremely great to get associated with them and have a drive at XLR campus. So we are very, very happy that we got a chance to do this. Now, coming to the students, what XLR had, I think they were extremely enthusiastic. They were well prepared. They were aware of what they are coming for. I think there was some back-end preparation which they did that was commendable. They also were very confident and they were open to any kind of thing we were asking them to do. That was I think the best part. Now, I really hope we have a very, very fruitful association with each one of them and XLR in future. We are really looking forward to have many more drives like this.
Hi everyone, my name is Prachi Sharma and I'm the Senior Project Manager for IT Department at 90th Percentile. So today we were here for this IT bootcamp, right, this technical drive and at XLR. So it was a great experience and I would feel that the students, they are the freshers, right, but it doesn't seem like that. So if I talk about their technical and cognitive ability, they all seems pretty good in that and that's what I felt. And I guess they have been taught pretty well at XLR, so that's how they have performed good in their aptitude and the technical tests. So I wish them all the best and it was a very great experience over here.
Technology Consulting Manager from 98th Percentile. We visited XLR for the campus placement drive and it went very well today. Ms. Ambika, Ms. Pragati, everyone received us greatly here and we had a lot of enjoyable time here. The students even had great experience with us. They were interactive, they had good aptitude and all the technological skills they showed. I think they were all well and we really appreciate their time that they spared to us and I think we will be doing a great job. We are expecting a lot of people to be hired from them. Let's see. it was a great experience altogether.
Thank you.
Thank you so much.
From entering into this cyber tower to exiting out of this tower, the XLR team has been received me with such a care and pleasure.
I am the part of this XLR since 4 months. From the third month itself, they have conducted the placement sessions from the third month itself, and this is the fourth month, and this is the 98th percentile is one of the placement drive I have attended so far, and attending to this drive is such a good experience for me. All the HRs and the team made us feel very comfortable and confident.
XLR helped me a lot, and I experienced a lot of things today. So I'm really hope to be I placed in that company. I'm confident about that. Thank you.
I am, shall I start? Okay. Hi everyone. So yesterday we have discussed Hive, and in Hive we have covered few concepts like the architecture of Hive, what are the various components available in Hive, and how we create table and load data in Hive, and what is the purpose of Hive in big data ecosystem. After that, we have covered few techniques, optimization techniques in Hive, and I've explained partitioning partitioning of table and how we implement partitioning while we load data in a Hive table. Also, we have discussed bucketing yesterday. Bucketing is again a data organization technique. We are organizing our data so that when we start retrieving the data, so less data will be scanned instead of scanning the whole table, our query will scan that particular partitions and retrieves the result faster. So that's why we use these two techniques, partitioning and bucketing. So then after that, we have covered joins, the various type of optimized joins like map join, bucket map join, sorted merge bucket map join. So we use these joins when there's a large and a small table, and we are joining the tables when tables are uneven. You can say one is small and one is large. Data is uneven in both the tables. Then only we can use these joins. Then uh, today I will discuss window functions in Hive and the various file formats available. So these techniques I will cover in the today's session. So let me connect with the environment first. So this is Cloudera only. The IP of this machine. This is the IP. So let's connect with this IP. Now here we can start Hive shell. Okay, Hive is connected. Also start the meta database. Meta Hive stores metadata in MySQL. So MySQL. Like, password is Cloudera only. Hmm. Okay. Now start MySQL shell. Show databases. Database is so Hive store its meta information in metastore. So use metastore and get the meta tables in Hive. These all are meta tables. Okay. Now so show tables. So these are the tables that we have created. Open HDFS as well, HDFS session. File system. Now data is stored. So this is the warehouse directory for Hive store its data in the warehouse. So this directory is fixed. This is where all the uh, Hive actual data is stored. Okay. Now the warehouse, all these tables are there. So these are partition tables. So as I said, that partition is used to segregate the data or to organize the data so that data retrieval is fast. Let me fire one query. So first, uh, I want to check how many partitions are there, what are the partition names. So that information we can retrieve from metadata tables. So these are meta tables. So here in this TVLS table, your information, meta information is stored. So describe TVLS. So here the information like the retention, data retention, the owner, the type of the table, when this table is created, all this type of information is stored here. So this partition table, this is the partition table. So this is the ID of that table. So check how many partitions are there in this table. So partitions is the meta table. So in this table, we can check for the table ID. Table ID 57. So here we can see there are total 168 partitions, and the partition names are this US, state, UK, South, Ayrshire, Yorkshire. So all these are the states, country and state pairs. Okay. So if we fire query on country and state pair, where country US and state California. So it's retrieve data from that partition only. So it has 72 records and data is retrieved in 3 seconds. So this data is actually retrieved from here. So if we check this directory, so we can see go inside this directory. This is US. So this is country and state pairs. Okay. So this California one is the one from where this one. Okay. This partition. So it scan this partition only. That's why this retrieval is fast. Now we discussed bucketing as well. So bucketing is slightly faster than partitioning, because in bucketing data is stored in files, and it has hashing concept. So it stored data based on hash codes. So if we check the table, bucket table, this is our bucket table. So check the buckets here. So So here, this is where our bucket table is created, this one, first one. So if I check the buckets, so these are the partitions, and within partitions we have buckets. Okay, so we can see these are the files, and these files holds data for country and state pairs. So hello file system ls, and we can check the data of this bucket, let's say. Okay, so now mm, so this is the file. In order to open this file, we need to write cat command. So it will show the data of this file. As we can see, it's showing some data. Okay, so that is about the partition and bucketing. So I just recall what we have implemented yesterday. And now let's start with the window functions. So window functions is used for, you can say, for some special scenarios. So let's say we have uh, departments. So we want to find out the highest salary in each and every department. So where so we can perform analytical operations using window functions, or we can do some aggregates. So these sort of uh, activities we can perform using these window functions. So let me show you some window functions. Okay, so we'll cover window functions later. First, first discuss with this point number E. Okay, so this is custom schema, or how we load um, nested schema. How we create nested schema based on nested data set in Hive. Okay, so we use standard data types. So in Hive we have these complex data type for nested data structures. For nested data structure, so first we have array. We have struct, then map. Okay, and within array we have array elements, struct and map. So let's see one example. Let me find some data. So this is my data set. Space this data here. Now format this data using JSON viewer. Now load this data in Hive table. So in order to load this data in a Hive table, first we need to create a table with complex data type or nested data types, because this data is nested. We have column inside columns. So That's why I'm calling this data set as nested data sets. Okay. So let's create the table. So create table. Um, table name is give any name to this table. That's the customer base. And now first is the message ID. The message ID is of type um, integer. Next is your message size. JSON data type. Yes, this is the JSON data type. So JSON or XML, both are nested data types. So we are trying to load this kind of data in Hive. In order to load this data in Hive, we need a table structure with nested data structures. So nested data structures, as I said, we have this array, struct, map. These all are nested data structure. So using these data types, I'm trying to create a table. And once this table is created, then we'll load this JSON data set. Okay. So this is the message ID. Next is the message type. Sorry, message ID is of type string because this value is in uh, double quote. Okay. So next column is message size, that is of integer type. Third is sender. Sender is again a string type column. So sender, and this is of string type. Next is your recipient. So recipient is of type array, and this array contains string type of values. Okay, recipient is done. Then comes the message part. So message part again is message part is again of type array, and this array contains a structure struct, and this structure contains two values. Extension is of type string, and then size is of type integer. Then your headers is of type map, and map contains key value pairs. So key is of type string and value is of type string. Your map close, and here this array 1 minute. This array is structure is closed first, array is closed second. So this table is created. So this is how we create a define the schema for a nested data type. So let me create the table. So they also created table. Let me copy this. As we can see, similar table they created. So this message ID, I created this. Then the message size. Then the recipient of the type array. Then message part is of type struct. And then headers, that is of type string. Okay. So we can create this is also a concept of internal table and external table. So when we create a table without a keyword, all tables are internal tables. So if we see here in the meta table, so show tables. So here we can see this table type is managed. So managed table is also called internal table. So whatever table we are creating, so all tables are the internal tables. And when we need external table, Then we use external keyword, but external table I will explain later. So now, we need a Java jar or JSON jar to store this JSON data sets. So we need to download a jar file. So let me give this format. Okay. And stored as we already defined. So trying to create this table. So it's saying that there's something wrong. Integer string of type array. Recipient is of type array again. It is fine. Okay. And then struct here array. Then extension string sizes of type int. There is something wrong there. Let me execute once again. DDL cannot validate this. So now this jar is missing. Okay. So we need to add this jar. So this jar contains JSON parser. So let's download this jar file. So just jar is here. Okay. So download this jar file. Why row format SerDe? That command is not clear. Let me download this first, then explain. So this is downloaded. So extract here. Give me 1 minute. I'm getting a call. Sorry, guys. There was some urgent call. So, yeah, we were working on this nested data set. So, we were trying to load a nested data set in a Hive table. So, this is our JSON data set, the nested data set, and we have created this table, but we need this SerDe. SerDe is a kind of Java code that is that do the parsing of the JSON data. So we need to add some external jar in Hive if we are um, using some extra features while we're trying to load the XML data. If any function is missing or anything, uh, we are you can say anything that is not available in Hive. So we can use those extra additional functions, and for that we need to add these jar files. So I've already downloaded this SerDe. So here, let me see the jar file if this is available. Uh, this is the okay. Let me compile this and package it. So using Maven, we can compile and do a packaging of this Java code. So Maven is a build tool that compile and package a Java code. So this build is failed due to this. Okay. Let me check. This one. Um, right now we are doing packaging and creating a jar file. And we will use that jar file to build, but this build is failed because it's not able to detect this library. So let me download this from some other location. You can directly download this. Okay, the jar is downloaded. Now use this jar file. This one. Extract it here. Okay. Now add this jar. Now first copy this jar from your Windows to the Cloudera environment. So just check the IP first. This is the IP. And it's 167. 167.1.67. Cloudera. Cloudera. Yes. Now it's connected to the Cloudera environment. Here on desktop, we'll have this jar file, Hive jar. This one SerDe. So just transfer this, and now check whether this is transferred or not. So on desktop, we have this jar. Where is the jar? This SerDe jar. Now registered it jar in Hive. So how to register a jar file in Hive server? What is WinSCP? WinSCP is used to transfer file or some data or anything from your local to your remote server. So this left hand side, this one is your Windows, and this one is the Cloudera right hand side. So I transferred file from my local to the Cloudera environment so that I can register that jar to the Hive server because Hive server is on Cloudera only. So add this jar on the Hive server. So add jar and then path of jar file. So here and what is the name of the jar? This Hive SerDe and then one version 1 dot jar. Now we can see this jar is successfully registered within Hive. We can do a list of jar as well. Okay, and we can see that this jar is now registered. Okay, now now we can create the table, this jar, uh, and this class is available. So this is the package name and this is the class name. So if we want to see the code, so uh, let's check the code. So here, if we go inside this is the package, and here this is the class that is doing the parsing of data. So this code is already written by Hive. So we just need to use that code. Okay. So just use that code to parse the data. So now create the table. So this is the table. Now it's throwing some other exception. Cannot validate SerDe. Okay, 1 minute. Uh, we have already added this, but this is the path. Next, this one is registered and also now create this table. And this table is just remove this location and remove this external keyword and now create this. Again, the same issue. This jar is not correct. Then let me check this one. What? Let me check this as well if it works. Actually, we need to detect the version, but this jar is not working. Let me check one more jar. Hive, JSON. SerDe jar. Let's check this one. Actually, there's a sometimes version mismatch. So that's also the reason. Let me clear the folder. SerDe and put this in this folder. Now download the SerDe. This, now this is downloading. Go and check this jar file. Paste it here. This one, this, let's check if that works. Transfer this file from your local to the cloud environment. File is transferred. Now register this unless and your jar is here. First, we need to register this. Add jar and path of jar file. Okay. Now go and check if this code, this table. Okay, we have one thing we need to take care. The class. So actually, when we are adding any jar, so we need to define this package. Now let's check the package. This is the package. Okay, this is the package. Let's copy this. This is the package. And the class name is, this is the project name. And these are the classes within this. So let's use this package. And execute. Again, it's failed. This jar is not correct. We need to check this uh, jar, then only we able to create, because this is important. Do the parsing. Let me check one last time if that works. Otherwise, I will share this jar tomorrow. So let me check this jar if that works. This is version JSON SerDe. CDH4. Um, Download the snapshot one. In the snapshot, what it is saying, this one for CDH4 and CDH5. CDH5. This is the final one. So let's copy this. Put it here. And now transfer this file from your local to Cloudera using WinSCP. Refresh it. This one transfer. Okay. Now here first we need to add in the JSON this in the Hive session. So your file is here, and now here add jar. And path of jar file. There's something wrong. Doesn't exist. JSON. Okay. Now it's added. Okay. Now we can use this here by creating our table. And this is the class. In this package, this class is available. Okay. So add this package here. And now create this class. Now it's throwing some other exception. DDL exception. So at least it's worked, because last job it was not detecting the class, but here this time it's detecting class. So first create this JSON file. Let's use this, and then we'll create our HTML. So this is the JSON file. So put this file in your HDFS. So using echo command, create a file test.json. Okay. And now using nano editor, open this file and put the data. Add these two JSON scripts here. Now this file is saved on desktop, and then upload this file on Cloudera. User Cloudera test.json. Put from local only. So home Cloudera desktop test.json, and this file is uploaded from the local to HDFS. Okay, so verify whether this file is uploaded. File system and I guess now we can see this JSON file is here, and also we can verify the content of this file. Okay, now verify the now create a table, external table in Hive. So now using this we can understand what is external table. So external table is is the table that is created outside of warehouse. So we need to define a location where outside of warehouse on which location our file is persisted, our data set is persisted. So now this location is the location outside of Hive warehouse. So user Cloudera is the location. Okay. And here we have test.json file. So using this file, we are creating this external table. Okay. And this is the direct load. We are loading this data in a single column, and the column should be of string type. So the whole JSON will be loaded into this column only. So let me execute this. Class JSON object inspector. In exception. Actually, this JSON is throwing the error, this jar file. Maybe because of the Cloudera version uh, or Hive version. Um, your Hive version is jar version 1.3.6 and the 1.3.7. Okay, let's check one more 1.3.7. 1.3.7. One point three point six. There is 7. Mm, 1.3.7. There is 1.3.7. Yeah, this one. Let's try this one again. 3.7. Now transfer this. Then this one. This one. 3.7. Actually, getting the correct jar is a issue. Echo command is used for creation of the of a file in Linux. Three point seven, 3.7. Here it's the jar is working fine, but this is the version compatibility thing. Version 3.6. What the dependencies? So the jar is working fine, but in case oh, this jar only. Objective placed. Mm, let's check this as well if that works. There's less probability that it will work, but we can give a try. So there is the jar file, this one. Register it. This is added. Now use it. Again, the same issue. So yeah, we'll resolve this problem later. I will look the correct jar because this is the compatibility issue. But the table creation is same that first we need to add this jar file. So this is how we added this jar in Hive session. And then when we are creating on a table, so here we need to define this class. This class is defined within this jar file only. Okay. So this class is doing the actual parsing of the data. So as we can see here, so this is the data set. If you see the data, where's the data? This one. So this is one data set. This is another data set. So when we load this data, so this country is of type string, language is of type array, religion is of type map. Map contains key value pairs. So here you can see this data here. So we are loading this type of data in a Hive table. So we need to create a table with the nested schema. And when we load the table, so this data is passed using these libraries. Okay. And simple load command we will use. And then we can query on this JSON data set. Okay. So same thing is explained again and again in this tutorial, you can say. Okay. Any question on JSON? How we load nested JSON? And how we work on nested data sets? We can see more examples. Let me show you one more. This is the message ID. Let's work on this. Okay, so this is my data set. They've also provided this jar. This is the same jar. JSON 1.3, 1.3. Let's check this as well if that works. 1.3. Okay. Refresh it. It's transferred. And now, first is the restore it. Registered. And now what is the class for this? So the class for this is OpenX JSON SerDe. So use this. Now create this table. Again, same stuff. It's very challenging. Okay. So now focus on the data. Jar we will handle later. So this is my JSON file. And now load this JSON into your Hive table. So first format this JSON. Where we get this class for SerDe? No, SerDe. SerDe is just a library. So correct library we need to find. Okay. So actually there's a version mismatch. I'm trying to add a different jars, but because of the Cloudera version or Hive version, these jars are not compatible. Maybe version 1.4 works or 1.5. So I need to check the actual version that is compatible to this current Hive version and the Cloudera version. That's the only um, thing missing. Otherwise, from Chrome every time, no. This is one-time activity. So we use, we have created this jar file one time. And yes, from internet only, we need to find this. These are the existing jars. If you are good in Java, just write a code to parse a JSON file and create your own jar. That is also the option. But we have existing parsers available. So I'm trying to use the existing parser instead of writing my own code. Okay. So that's why I'm going on Google and find out the jar, correct jar. Correct. Now this is my data. I have formatted the data set, this one. And now create the table, load this nested data in Hive table. So we need to create a schema for this. So create schema. Now create table orders. Now in the orders table, first this is the detail column. So detail column is of type struct. Detail column is of type struct. Even after sessions are over, this is only for the new sessions. Okay. So right now we have created Hive shell. So when I close this session, so everything is lost. This jar only. So this jar is added for temporary basis. If you want to permanently add this jar, so go to the Hive server. You can go there in Hive, and here Hive is available here. Hive. Hive is here, and inside library folder here, place the file and restart the server. So it will be permanently added to the Hive server. Okay, this is the permanent way. But if you want to temporary check, so add in the session only. That is on temporary basis. So now here, what I'm trying to do here, this is the nested data set, and I'm creating a table based on this nested data using standard data types. So details is a struct. There's a structure only. Inside the structure, first name is the column that is of type string. This column is a type string. Then the last name is all is a column that is of type string as well. Then the orders, the third column. This column is of type array. Okay. And now this array contains a column ID, and ID column is of type integer. So now this ID close, array close, and this table is closed. Okay. So this is how we create uh, the this is how we create the table based on nested data structures or nested data sets. So once this table is created, now you need to use this jar again to load the data. So at here you need to add this SerDe. SerDe is a Java class. These are pre-existing class, and here these classes are just the parsers that are converting JSON values into string. Okay. So that is for the nested data structure. Let me check if we can check more examples. So the more examples available. This is the file. This one we can check. Let me check a nested JSON. This is the small one. Let's check this. I will create a table. So this is again a JSON, and now create table based on this JSON file. So here so first is create table test. Now first ID column that is of type string. Then the user friend count. User friend count is a column that is of type struct. Okay. ID friend count. Struct, and in this structure we have a column called int, and its value is of type int only. So it gives column name as int only. My user location is of type this is again struct that contains string type of values. In this struct contain integer type values. And then we have user description. It also contains, it has struct, and that struct contains string type values. Then status count, then follower count, username, screen name, created at. So this is one structure. Then This is another structure, retweet counter. So checking the data and create these table structures. That is important when we are working with this nested data sets. Okay. Any questions so far? Okay. So next is uh, internal and external table. So what is internal table? Why we use internal table and why we use external table? So whatever tables we are creating currently, all are internal tables. And when we use the external keyword, so it will create external table. But for external tables, we need to provide the location where this data is. This is the external location where your data will be stored. Otherwise, the in case of internal table, your data is stored in warehouse directory, and that directory is fixed. But when something is outside of that directory, outside of warehouse, so if we can check here, so user Hive warehouse. This is the directory where all the internal tables are stored. So all this data is reference to internal table only. Okay. External table is outside of this location. It can be inside SDFS or and outside of SDFS, let's say on cloud or no, in NoSQL databases also. So on those external storages also, we can create a Hive table on top of that. And that table should be an external table that reference external location. Okay. So let's see this table. External table. A simple table we can create. So we have this data set available. Now create this table as external table. Now here we just need to write external keyword. And also the location we need to provide. So that is this is how we define the location. Whose now give this table. So this table is created. Something let's check the metadata of this table. What is it? This is the external table. See, here it is showing the table type as external. So this table data is stored in some external location that is outside of Hive warehouse. Okay. Any question on this? What is internal table? What is external table? And if we drop a internal table, its metadata and actual data is lost. And if we drop a external table, its actual data is lost, but the its metadata is intact and actual data is lost. So we can recover the external table. But if internal table is dropped, it's everything is dropped in case of internal table because it's all the metadata and the actual data both lost if we drop an internal table. Let's uh, check this. So tables. And here we have this post 123. This is internal table. So drop table table name. So if I drop this table, so first check the actual data in HDFS. So if we go in HDFS and check user Hive warehouse, because our data is stored in warehouse only, the internal table data. And here we can check that when we drop this table, what is the table name? Post 123. So post 123 is dropped from warehouse as well. And if we check the metadata, in metadata also, this post 123 is disappeared. So this shows that whenever we drop a internal table, its metadata and actual data is lost. Now let's drop this external table. So now check its metadata first. Actually, this table is not created with this location. So let me read one more time. Okay, now it's created with external location. We can verify the path of this table. When we load the data, then it should be visible here. Okay, but for any Hadoop platform, the table metadata always stored in MySQL. No, it's stored in any RDBMS resource. So I explained this yesterday that Cloudera provided this platform and they have pre-installed everything within this bundle, this CDS bundle. Okay, so if we go and check that this is the Hive, and in the configurations, or you can say in the script section, they provide these metadata scripts. So when we install Hive, during the installation time, we decide which database we need to choose or where we keep our metadata information. So we provide Postgres, Oracle, MySQL, MS SQL, Derby, all these databases it support. So Cloudera choose MySQL only. But if you want to choose Oracle, Postgre, or any other database, so choose that database and execute these scripts on that database, and it will create all the metatables. Okay. So MySQL, Cloudera choose MySQL only, but table schema and information is same. Nothing is changed. If you switch from database to database. Information is still the same, and the purpose of metadata is still the same. It will not change anything. It's just the environment change. Okay, it will keep this kind of information only. Okay. So I was explaining internal and external table. So let's drop the external table now. Table is dropped. We can see even if I drop the table, its metadata is still intact. So that is the case with external table. Internal table metadata and actual data both are lost. When external table, its metadata is still intact. Only the actual data from HTTPS is lost. So this is about internal and external table. Okay. Any question so far? Hello. Any question? Do I repeat anything? Anything is missed, or you guys didn't understand? Do let me know. The window function, I will pick this topic later. It's a bigger concept, and file format is also a bigger concept. So these two topics I will pick tomorrow. So custom schema, we have nested schema we have covered, and how we load nested data types, that also we have covered. In case of JSON, we need JSON SerDe jar, and in case of XML, we need XML SerDe. And these SerDe are nothing; these are just the Java codes, and these Java codes are used to parse the JSON and XML datasets. So JSON uh, JSON parser converts the JSON file format into string using this SerDe, and XML SerDe converts XML file formats into string. So that's the whole purpose of these SerDes. And Hive is full of SerDe. Hive is built on MapReduce means Java. So everything uh, is wrapped in these SerDe jars instead of writing MapReduce. Okay. So let me open. Static and dynamic partition, can we do it on internal table or external? So internal table, yes, we do partition on internal table that we seen yesterday. And Hive internal tables is within the control of Hive. But when we create an external table, so Hive, you can say Hive security or Hive properties is not applicable to the outside locations. Okay. So internal, yes, sure, we can create those partitions. Even in external locations also we can create partitions. But thing is, some security features or some features are not applicable on external table because that is outside the reach of um, Hive. Okay. So let's discuss these points. So now we have covered so many things. So what you guys understood after using Hive? So we have covered Scoop and Hive, and we can say both are alternates for MapReduce. Scoop is for ingestion purpose, and it's ingest structured data only. It's not able to ingest unstructured feeds, just the structured feeds from databases into data lake Hadoop. There's no transformation, just a plain extract and load. That's why I'm saying data ingestion tool. Now, once data is loaded in the data lake inside Hadoop, then we need some sort of tool to analyze that data. So that is where Hive came in the picture. So it's a SQL-like engine on top of HDFS, but to uh, uh, in order to, you can say, implement the Hive properties. So this structure we need to follow. So we need to load our data into Hive tables first, and we see Hive is just a virtual environment. So Hive store its metadata in some RDBMS and it stores its actual data in HDFS only. So better is to pass the data through Hive table. This direct load into HDFS is not a good option because once you dump this data directly into HDFS, then it is of no use. You're not able to analyze, you're not able to run any queries, nothing. So better is to keep load that data in Hive that will store in HDFS only, and it provide a flexibility to run queries. Okay. So now here, as I said, it's a data warehousing package, or you can say SQL interface on top of Hadoop. And also it provide a SQL language, okay, that we already seen that it's a SQL interface. Attendance link is already shared here, this. So it's a SQL-like interface on top of HDFS. And this, the SQL language that is used, they are calling it as Hive query language. So it's nothing, it's SQL only, just because this is used by Hive, so they are calling it as Hive query language, but it's SQL only. And as I said, it's a tool that is used for business insights, for reports, for data analysis on top of HDFS. And Hive queries are converted into MapReduce. That process automatically happens within Hive server. So if we see here, as I said, Hive client, this is where we writing our Hive job. And these Hive jobs are submitted on Hive server. Then Hive server convert this job into MapReduce that will do the processing on this Hadoop cluster. Okay. So, and this tool is developed by Facebook only. And as we are saying that Hive is a SQL interface, so some people think that this is a relational database. No, it's not a database. It's a querying tool. And it, yes, Hive uses a database, but it uses database to store metadata, not the actual data. And the data that actually processed by Hive that is stored in HDFS only. Okay. It's a OLAP tool, online analytical processing tool. It's not a transaction processing. So, or OLTP. So RDBMS, those are OLTP databases. So mainly used for the transactional purpose. And Hive is used for the analytical purpose. Okay. So, so here it's written that there's no need to learn Java because MapReduce is the tool through which we can interact with HDFS. But as we are not familiar with HDFS, it's a wrapper on top of MapReduce. So we are writing SQL, that SQL is converted into Java code and that interacts with HDFS. Okay. So, and it uses SQL only. So that's the advantage. And if we compare Hive with RDBMS, so in RDBMS, we need to write tables. Okay. And here in Hive, doesn't verify the data is loaded, but rather when we fire the queries, then it detects the schema on the read. Okay. So this is Hive architecture. Now this is cleared. Yesterday I showed multiple times, but see, now we have implemented this thing on this interface. Now we are pretty much clear that. So we are interacting with CLI only, but it provides a web interface. Let me show you the web interface. If we go and check this web interface, this one. So here, this is the web interface, and here we can write our queries. These are the tables that we have created. So this partition table where country and these other inbuilt functions. Okay, so this Hive is full of functions, inbuilt functions, and the functions that are not available. In that case, we create our own functions, user-defined function. So user-defined functions I will cover tomorrow. So you see the UDFs. These are user-defined function. So, and these functions are related to all analytical functions, right? So where country, use. Okay. So if you execute this, it execute the results on the Hive server. So this is your web interface, and we are calling this as Beeline interface. So and right now we are accessing data lake environment, so that's why we are using these interfaces. But we can connect externally as well using our Java code. Okay, so um, this JDBC connector we can use to connect. So I will show you that one also tomorrow. Hive components, the meta store. I'm telling again and again that it's this is the metadata, and metadata information here it store the creation time, the retention time, who created this table, what all columns are available. This high level information is stored in the meta table. Okay, so it's a central repository for Hive metadata. Now the execution engine. So execution engine is the default engine. Okay, so whenever we submit our jobs on the Hive cluster, those jobs are converted into MapReduce. Okay, and also Hive contains compiler and optimizer. So it try to auto optimize the joins, auto optimize the jobs that were submitted. So now Hive services. So these are the interfaces and tools that we used. So command line, we are continuously using this command line interface to interact with Hive. CLI is the JDBC one using Java code. What is the difference between Penthouse integration tool and Hive? Penthouse is a Cloudera-like environment, I believe. So OLAP, yeah. So both are same then. If it is a OLAP, then Penthouse, Presto, Athena, Hive, there are a lot of tools available. Those are OLAP only. OLAP means ETL scripts can written. So that's why I'm saying uh, this Hive is also it's doing extraction, doing analysis, doing transformation, and load. But Hive do processing within SDFS only. So let me explain this. So let's say you have this is your HDFS, and you have created a Hive table. Okay, this is your HDFS, and here we have Hive. So this is table one. This is table one, and this is table two. Now, some data is available in the source, let's say in Oracle. This is Oracle only. And now from Oracle, first data is ingested into this table. Okay. So that activity is performed by Scoop. Now, once this table data is inserted into this table one, then it will persisted here in HDFS. And in HDFS, it persisted in this warehouse directory. Okay, now here with Scope, we can ingest directly data from MySQL to Hadoop storage by using path of that file in Hadoop. We are able to create empty tables in Hive, and then we can load data in empty tables by referring that file path. Is that correct? Yeah, it's correct. We can load data into Hive tables using Scoop. So this is what I'm showing. And now this is the raw table. This is the raw table that contains the raw data. Okay. Now we will write a job. On top of that, we will write a job. Just 1 minute. We read the data, then transform it, and then we write the data into another table, this table, after transformation. So this is the aggregated table, or you can say the table that contains the transformed result. Okay. So here we write these HQL to read from this table and then write into another table after transformation. Okay. And now from this table, the result will be shown to some dashboard, let's say Power BI or Tableau or any other BI tool, business insight tool. So this is called analytical processing, OLAP, online, and this is a OLAP tool, online analytical processing engine. Okay. So HDFS, your Hive is here only. Okay. Now it's not interacting with external environments. It's doing processing, because for processing it needs SDFS only. And you see after transformation, that data is again loaded back to HDFS in some location, in some warehouse directory. So it's just a wrapper on top of HDFS. So now, in order to connect with Hive, as I said, we have CLI, we have Beeline interface, that is a web interface. We can also connect using JDBC client as well. So for JDBC connection, we can write Python code or Java code and use JDBC library to connect with Hive. So here in this diagram, we can see all the components, how these components are connected together. Have a look on to this architecture, how these components are connected together. Okay. So this is Hive driver. So when we submit our queries, so it will go to the Hive driver, and then it compiles and optimize that query and then execute that query on the HDFS. This is the processing engine for Hive, and its metadata is stored in parallel in these RDB resources. Meta stories of three types. I discussed this yesterday, that embedded meta store, local meta store, and remote meta store. This one, embedded one, is we never prefer, because if we submit multiple jobs on the Hive server, then it's not able to store the data from multiple sessions at the same time, because Derby is a memory database and it store its meta information in cache only, in the memory. So we need, whenever we submit multiple jobs, so there are concurrent ones. So concurrently, two threads can write data in these RDB sources. So, and that's why we prefer RDBMS, or we have remote meta store. Remote meta store is installed outside of Hive, you can say, instance. This here meta store thread is running within Hive server only, but here this meta store JVM is running outside of Hive instance. That's the only difference. So as we can say, by default, the meta store service runs on the same JVM. So actually, Hive is a tool based on Java, and Java use JVM for its execution. So this meta store service use the same JVM that Hive driver is using. Okay. So this is called uh, local meta store. But in case of remote meta store, that metadata service is installed outside of Hive service. Okay. That is regarding data types. Yes, we already covered these data types. These are the normal data type that we use in SQL. And these are the standard ones. Today we have discussed this, why we use, where we use array, map, struct, and unions. Okay. We create two types of table in Hive. So internal table and external table. Internal tables by default, directory for internal table, or we can say managed table, is this only. So every time we are creating a table, it's stored in this directory within HDFS. Okay. Metadata and the actual data is managed by Hive in case of internal table. Uh, when we, in case we drop the internal table, so it's data, metadata, and actual data both lost. Okay. Data resides in HDFS and metadata is stored in metastore. And now metastore, we choose with our own that which database we will use for storing the meta information. So when data is not using by multiple users or not updated by multiple resources, we use internal tables. If we process with data with the Hive, then only internal table will be used. So internal table data is more secure because the governance, security, everything is managed by Hive only on internal tables. But if there's an external table, that table data is stored outside of this directory. Now it's within HDFS or outside means in some external environment like AWS S3, in cloud environment, or in NoSQL databases. Okay. So it's not stored in the warehouse directory. That data is not managed by Hive. Hive does not delete the table. So that thing I already shown, that if we drop a table, external table, so that table untouched and only metadata of that table is deleted. Table data is still there. Okay. Data resides in HDFS and metadata is stored in Metastore. So when data size is large or data is uses updated by multiple resources, we use external table. If we want to use Hive and some other tool to process, then use external table. Okay. So that is about internal and external tables. Hive HQL So the language that we are using to write Hive scripts, these are Hive scripts. So here uh, it's a SQL language, okay? Filter based on conditions. We can store the result of a query in Hadoop, yes, in another table. So that is this scenario it's saying that for result of one, if we query the result from this table, then the aggregated result we can store in another table. Okay, we can manage tables and partitions. Yes, we create partition and bucket tables. Multi-table insert is supported. It converts SQL queries into MapReduce. Yes, we are seeing that. It support custom MapReduce scripts also. And this query language uses familiar SQL operations or SQL functions. All similar functions is used. Okay. Now partitioning, we already discussed this, that organizing the data in so that your table scan is reduced, or you are slicing the data so that your Hive queries will be fast. Okay, we do a partitioning by partition by function. Okay, and inside it we define the party columns, on which column we need to create our partitions. This is static partition. So here we knew that in our data file, these are the distinct partition pairs available. So we can pass those distinct pairs in our load command that will create the static partition, or we can say we are manually creating partitions. Buckets is again a data organization technique, but here, as I said, bucket is fast. It stores data in a file, not in a table or a directory. Partition is kind of a directory. Bucket is a file. Okay. And bucket uses hashing algorithm internally. So if we have a hash code, so that data retrieval is fast because uses hash code, it directly search the bucket address and it will filter out the data from that bucket only. So bucketing is fast because of hashing. And clustered by is the function we use to create our buckets. Now order by, sort by, distribute by, cluster by. So these are various sorting available in Hive. This I will discuss tomorrow. Joins we already discussed that they are special. These are standard joins that it supports, but there are some special joins like map join, bucket map join, sorted join. So when we have a small and a large table, then only we perform this join. Otherwise, normal joins Hive supports. Okay, so user-defined function, this is the topic for tomorrow. So I will start from user-defined functions tomorrow. And after user-defined function, then the pending topics are window functions, Hive file formats, incremental load, and Hive user-defined functions. So these are few pending topics that will finish tomorrow. And then after that, we'll have a Spark, one scheduler Uzi, and one NoSQL database HBase. These are the three pending topics after tomorrow. Yes, I will send this PDF. Any question, any concern? I'm unable to find material. So could you tell me where you have to share the material, either Drive or Excel, our website? So, Amar, have you shared the material?
Yeah, sure. Once again, today I will share that which drive link you shared with me. Now I will share in the WhatsApp group.
Yeah, because it's there on the drive.
So you updated recent material in that drive.
Yes, yes. You see, there is scope material is here, and you have
Okay, sure.
day one material.
Yeah, now
Yes.
only I will share that material in the WhatsApp groups.
So and Hive also I will upload after this session.
Okay, sure.
You have everything here. So just share this day one, day two scripts, the folders. Okay. Any other question? Any other question? We don't have access of this drive. So Amar will share. He will upload on XLR dashboard. Correct, Amar?
Yes, right. And one more thing. So participant not required to share the editor access. So you have to simply download that file and you are able to access that. Okay.
Okay, so that's it for okay, SerDe. So SerDe, these are the jars, Java jars, and these are the Java codes. So if we are using some external functionality, let's say the JSON we are trying to load. So JSON, you can say parser is not available in Hive. So we need to add the SerDe jar, the Java jar. So from explicitly we need to add so that we can parse our JSON data sets. So for XML, you have XML SerDe. So, and also this internal, the partition, bucketing, and internal table, external tables, everything. They, Hive is full of jars only. And these jars are SerDe jars. Some are inbuilt, some we explicitly add in Hive. So these are Java codes only. Because Hive is a SQL-like interface. So whenever we are performing any operations, it converted into the Java code. So if some functionality is missing, we can explicitly add those jars in form of SerDe only. Okay, SerDe means serialization, deserialization. Okay, okay. Thanks everyone. We'll continue tomorrow. Thanks everyone. Thanks for your time. Thanks. Bye. Okay, I see one more question. How to get in big data domain as a fresher from non-tech? If we have had hands-on experience of big data too, please guide. Sagar, you can connect with me separately. Okay. So Amar, share my number to Sagar. I will explain him on call.
Yeah, sure.
Okay. Thanks. Bye.
Participant, I already shared the attendance link in the chat box multiple times. So I'm requesting you please mark your attendance.